Thank you very much to the organizers for this invitation to talk to you about our Open Topography project and how we've been working to advance surface process studies with open access to high-resolution topography. High-resolution topography is collected from many platforms. It can be space-based, and we see both laser and photogrammetric approaches as well as radar. But most of our emphasis in our work has been on airborne and terrestrial platforms, both laser scanning and photogrammetric or structure from motion. Open Topography is dedicated to democratizing online access to high-resolution topography. That means lidar, photogrammetry, satellite-derived data, and we have a tiered access to these data from raw point clouds to easy-to-use derived products, and we try to co-locate the data and processing tools. So you should certainly check us out at this website, www.opentopography.org. Open Topography data services include these, where we have this range of available products that vary from kind of ease of use, like these KMZ hill shades, to point clouds, which are, and also custom digital elevation models. And we see the trade-off between that ease of use and the data volume, computational demands, and the needs of our users. We find that the majority of users want a standard gridded product like a digital terrain model or digital surface model, but we're always seeing more and more demand for point cloud analysis. And we have multiple access pathways, both the web-based portal and API access. So the Open Topography core services include the data hosting, processing that includes filtering and subsetting, raster data subsetting, and then computation of digital elevation models using tin-based or local gridding approaches. This is done on the fly. We can compute things like canopy height models and derive products like topographic hill shades. We have 3D visualization as possible. And then some of our latest work is on vertical and 3D topographic differencing. And finally, we have high performance computation of drainage network properties using a supercomputer implementation of the TauDem toolkit. So Open Topography has the easiest way to get at data is just go to our portal and identify an area of interest in the world and then start to explore. Here you can see two different data sets. The red are the data sets that are hosted within Open Topography. The green are data sets that we make access to in a value-added way from the US Geological Survey. And a few of the blue dots, actually a third data set, are user-provided data from the community DataSpace. Once you've identified a certain area, you can then see all the polygons that you've intersected in that volume and see both our data, the USGS data, community contributed, and we have also global data, which includes 30-meter SRTM data and several other global raster data sets. Once you identify something of interest, you can click on that data set, and we pride ourselves on high-quality metadata. Here we're zooming into the Wasatch Front in the U.S. city of Salt Lake, and we can carefully pick through and identify data formats, computational parameters, for example, how to make the digital elevation model, customize these settings, and then have an output that you can keep track of through My Open Topo. And this will also includes browsable products like these hill shades and colored hill shade, but also we have 3D point cloud viewing capability through the Potri Entwine system, and this is the Capitol building of the state of Utah in Salt Lake City, and so you can see real-time 5.5 million points viewed in the browser. Quite exciting, and we think this is a place where we'll continue to grow in our services. So the other way to access data is through our API and the bulk access. And so you see here most of the data that are available right now through the API are the global data sets, which are listed here: SRTM, ALOS World 3D, NASA DEM, and Copernicus DEMs. And so these are possible to access fairly straightforwardly. We also have access to cloud optimized geotiffs. The other thing that we've really explored is the need for what we call long tail data, so data that have a lot of value to a few scientists but are otherwise not taken care of in terms of a data management scheme. And that's in contrast to data that have kind of coordinated infrastructure associated with their collection and storage. And so with these groups, we have partnerships, memorandums of understanding, and service agreements, but we've enabled a way for users to upload data that they've collected and produced. And so this is very exciting. It allows users to do a lot of the loading and curation themselves, but once they're uploaded and validated, registered, they're available and discoverable anywhere in the world. So OpenTopography has an impact on research. We have supported more than 477 peer-reviewed publications, many master's and PhD theses, and numerous books and reports. You can see we are seen both as a data source as well as a data resource. And so we hope that if you use OpenTopography data, you'll acknowledge this, use the DOIs, cite us so that we can help measure our impact. And you see the topics right now tend to be remote sensing, GIS, computer science, cyber infrastructure, earth and natural sciences, but we're hoping to grow and broaden our impact. So other areas we have impact is in education. So you see online resources. For example, we started to make available Jupyter notebooks. We also have various online tutorials and virtual experiences. And then, of course, we try our best to do as many in-person workshops as we can. The other thing that we see as a big impact is data providers. We see our effort as a value proposition to data providers where we help make their data more usable and have higher impact. One example is the New Zealand National LiDAR program from Land Information New Zealand. And so we have 39 data sets covering 53,000 square kilometers, and you see soon maybe all of New Zealand will be covered, but you see these really beautiful products and science applications, also engineering applications are quite evident. Other novel uses, we see a lot of interest and access in the OpenTopography data for gaming and virtual environments, also in this case tactile learning and 3D printing. Finally, the biggest thing and why we said 30 trillion points in the title of the presentation is the U.S. Geological Survey has a program called the 3D Elevation Program, which is partnerships with local agencies to collect data that cover the entire U.S. LiDAR and then IFSAR for Alaska. And this is a big set of data, but it's clear that these will have great impact and great return on the investment. Much of the investment goes into the acquisition, and we are part of a number of pathways to make the data available. Are able to work with colleagues who have enabled access to LiDAR data from Amazon as a public data set. And this is very exciting. Our functionality is a value-added service to these data, which enables us to increase the impact of the investment in them. And so you can see this is from just a few weeks ago what the coverage is. It's constantly changing, but all of the green polygons are airborne laser scanning data covering the lower 48 of the US. This is a huge amount of data, 30 trillion LiDAR returns, and growing all the time. And the exciting thing is once we have these data, then there will be a push to repeat the coverage, and we can really begin to explore things in the sense of change. And here's one quick example of change detection in a part of Indiana. And so we start to see geomorphic changes, lots of vegetation, also construction. And we think that these big data computations will be really revolutionary as a sort of four-dimensional topography that we all know we'll need to answer the questions we're going after. So with that, I want to thank you for your attention. Please keep in touch with us. Thanks to Professor Taroli for his guidance, and also want to make everyone aware of a paper we published recently where you can learn more. And thanks especially to the U.S. National Science Foundation for its support.